Hi everybody, today I'll be discussing glycolysis. Let's first begin by defining what glycolysis is. It's essentially a reaction where energy is extracted from glucose. And the molecule, glucose, is split into two 3-carbon molecules called pyruvate. And this all takes place in the cytosol of the cell. And it occurs in two phases. I'll split it I'll first start discussing the energy requiring phase of glycolysis, and then I'll discuss the energy releasing phase. So for the energy requiring phase, glucose gets two phosphate groups hooked onto it or attached to it. And once this occurs, the sugar has been modified and it's now called fructose 1,6-biphosphate. And this is an unstable molecule. So this unstable molecule is split in half, and that forms the two 3-carbon sugars with attached phosphate groups. Now, one of those 3-carbon sugars is DHAP. The other is glyceraldehyde 3-phosphate. And in these steps that just have occurred, their ATP is getting used up. So 2 ATP get used up in this energy requiring phase of glycolysis. For the energy releasing phase, each of those 3-carbon sugars that were made, the glyceraldehyde 3-phosphate, are converted. And I should mention, let me go back one slide, this DHAP actually undergoes another reaction and does get converted into glyceraldehyde 3-phosphate. Say that fast 3 times. So now that we have the glyceraldehyde 3-phosphate molecules, the 3-carbon sugars, there's a series of reactions that are going to occur, and the pyruvate is going to be made. Again, 2 ATP molecules and 1 NADH molecule are made, and this occurs twice because there's 2 3-carbon sugars. So if you do the math, I can actually do this one without my calculator, you get 4 ATP and 2 NADH. Each reaction, of course, in glycolysis requires its own enzyme. So the most important enzyme in glycolysis for regulation is phosphofructokinase. And that will either amp up or slow down, so speed up or slow down the glycolysis process, depending on what that cell needs for energy. I've got a diagram here that I liked. If I had done it, you wouldn't be able to read my handwriting. So again, you have your glucose molecule being converted to the fructose 1,6-biphosphate molecule. That's further split. You get the DHAP, which eventually will be converted to the glyceraldehyde 3-phosphate, and you get the other glyceraldehyde 3-phosphate molecule, and you have the end product of pyruvate forming. That happens twice because you have 2 molecules. So that was the quick and dirty on glycolysis. It's over, so now what do we do, or what do we have? So we're left, as I just talked about, with 2 ATP and 2 NADH and 2 pyruvate molecules. If oxygen is available, that pyruvate can be further broken down into carbon dioxide during cellular respiration, which we'll talk about, to make more ATP. What happens to NADH? If oxygen is present, it can pass its electrons to the electron transport change, and then that NAD can be regenerated for use again in glycolysis, and bonus, ATP, more ATP gets made. So in summary, glycolysis converts 1 6-carbon molecule of glucose, so we're taking 1 molecule of glucose and converting it into 2 3-carbon molecules of pyruvate. The net products, or what we get, what's in it for us, we get 2 ATP, 4 actually are produced because 2 are used up. But the net is 2, and 2 molecules of NADH. As always, let me know if you have any questions. We'll see you next time.